Okay, we are on lesson 3.4 today, which is looking at linear and exponential functions. So we're going to start off just kind of looking at the table and graphing that, kind of what we're used to, and then look at more of the equation version. So when we're given a table, remember we want to kind of look for a pattern. So I want you to take a minute and see if you can find the pattern and just kind of show that on this table. So for example, I'll try the x side and show you that. So on the x side of this one, 1 to 2, well, that added 1. And then 2 to 3, that also added 1. 3 to 4 added 1. So look at that on the left side and see what's happening there. Okay, hopefully you have had a minute to kind of glance at that. So in that you realized it went up 3 each time, and my arrows got a little off right here, but you get the idea. So that is still kind of the same as before. So if I wanted the slope of this table, I do the y change, or the pattern, over the x change, which in this case would be 3 over 1, or just 3. Okay, now if I was going to graph this, so each of these on the table is a point on the graph. So I could put these, bottom here is my x, this is my y, so this is only the positive quadrant on the graph. So I would do 1, oh, that one's actually -1, my bad, so that goes off. 2, 2, 3, 5, 4, 8. Okay, so that's how those points would look graphed. And then if we're looking at the equation, in this case, remember usually this is y equals, but we said last class that f of x is the same as y. It's just showing us that the equation we're talking about, or the relation we're talking about, is in fact a function, okay? So here f of x equals mx plus b, and hopefully you remember this, but, or actually I'm going to label this here. So m is the slope, or the rate of change, those are the same, and b is the y-intercept, or the initial value. You can think of it as initial value, starting point, etc. Okay, so basically relations written in this form, this f of x equals mx plus b, or where they have this constant rate of change going on, so all this changed by the same amount each time, or when on the graph they form a straight line like that. I'm just going to write that there actually. So these are what's called linear functions. All right, so those are kind of some ways to identify those. They're written in slope-intercept form, they form a straight line, or they have a constant rate of change on a table. So I'm going to look now at the second relation that we have. So again, we're looking for the pattern on the table. So like this, again, the left side goes up by 1. So take a minute and try to find the pattern on the right for the y values. All right, hopefully you found that pattern, and it is actually decreasing, so it's going to have a negative slope. And you may have realized, so don't write this yet, that first time it went down by 4. Oh, well then it went down by 2, and then 1. So that's not constant. If that happens, kind of take a step back and think, okay, well, what else could I do to that? So you may see, well, like what number could I divide by? So in this case, I could divide by 2, which would work. But when we get to our equation over here right here on the right side, we are actually multiplying. So anytime you're dividing, you can also multiply to get that same result, but to get a smaller number, you're going to multiply by a fraction, okay? So in this case, if I was dividing by 2, that is the same thing as multiply by 1/2. So when you multiply by half, it's like taking half or dividing by 2. And let's see if that keeps working. Well, 4 times 1/2 is 2. And just a reminder, this could also be written as 0.5, and then 2 times 1/2 is 1. So that is working out there. All right, so it is still doing the same thing, which is good, okay, but it is not adding or subtracting like we did in our linear function. So we're multiplying by 1/2. All right, again, let's look at these as ordered pairs on the graph. So 1, the right 1, up 8. Puts me right here. 2, 4, so 1, 2. 3, 2. 4, 1. Okay. So if you see here, looking at that, you can tell it does not form a straight line. And I'm going to write over here multiplying by 1/2. I'm going to come back to that. All right, so if you get this sort of relation where you're realizing, okay, well, this isn't forming a straight line, it's multiplying instead of adding each time, there's a new form for our equation. So we still have this y equals, and I'm actually going to write f of x because we could also do that, right? Because if you look at this graph, it is still a function. It passes the vertical line test. It's just not a linear function. So I'm looking at this equation here. This is the format I want to write that in. So A is your y-intercept or initial value, and B is your multiplier. So the number being multiplied each time. And x stays the same, just like each equation for slope-intercept has an xy, and so does this. So I'm going to write that with, so I could write it, or y equals a times b to the x power, or f of x equals a times b to the x power. So in this case, if I were to plug in, I would want to say, okay, I'm going to keep f of x. My starting point I actually did not have, which I can go back and get that in a minute. So let's look at that. If my starting point has an x value of 0, okay? So if I was timesing by half each time over here, I want to think, okay, if I'm timesing by half above the 8, what would I have to have as my y value for half of it to be 8? So hopefully you've thought of 16. So 16 times half would give us 8, so that's good. All right, so that means that is my starting point, or my A. My multiplier was 1/2, and I put x in the exponent spot, or I could also put 0.5x, if you recall. Either of those would work. All right, so when this is not forming a straight line like this one did, it's called a nonlinear function. In this case, it's also specifically exponential. So I'm going to say nonlinear / exponential function. Okay, and this is just kind of a reminder down here on this table in case you need to look back. So for exponential, like we just looked at, the y values are multiplied by the same number, so you can work backwards and divide to find that number. The graph is a curved line towards the x-axis, as we saw here, and the equation will have x as an exponent in the equation written like this. Or they can also stick a and b together instead of putting that dot in there. All right, for the linear, like we saw on the top, the y values will be adding the same number each time, or adding a negative, and then the graph made a straight line if we connected those dots, and the equation will be written in slope-intercept form like y equals mx plus b. All right, now we're going to practice. So if you need to flip back to your notes, okay, and it would, so it's going up at the same amount like our linear functions. So I'm going to use my slope-intercept form, but I'm going to do f of x. This on identifying these, so we're going to look at kind of those patterns we saw in the notes on our first page and kind of see if we can pick these out. So tell if each relation represents a linear or exponential function, and then write the equations on the starred numbers. So like 1 and 2 have the little star beside it. All right, first thing I want to look at is finding the pattern. So in this case, Lon's mode amount paid is what we're looking at. If you're trying to figure out which is x, which is y, you want to think about x is your input. All right, here, let me write that. Write that somewhere else. I'll put it over here. And y equals your output. So you want to think, okay, which one is affecting the y? So in this case, is the amount paid affected by how many lawns I mow, or is how many lawns mowed affected by how much I paid? So, well, in this case, lawns mowed is x, because the more lawns, the more my money goes up, right? I don't get paid for lawns that I haven't mowed. All right, so I'm going to look for the pattern. X's are all going up by 1s. That's pretty typical. All right. Okay, well, the first one is plus 12, so we have to make sure that keeps working. Worked there, and there, and there, there. So yes, it worked all the way up. They added 12. All right, so then in that case, that means it's a constant rate of change for y. So it'll be f of x equals, well, 12 over 1 is my slope, so that's the same as 12x. And then I need to look, I do not have my starting point because I don't have x of 0, which I need. So, okay, 0 plus 1 is 1. I want to think, all right, what plus 12 would give me 12? And that would have to be 0. So if my starting point is 0, I don't actually need to put that because 0 doesn't change anything. So I can just erase that off of there, and this would be my final answer. All right. I want you to take a pause and try number 2 all on your own. Okay, hopefully you're checking your answer now. So the ones were going up the same amount each time. And I looked, okay, 3 to 9, well, that went up 6. But if I do that again, it does not go up 6 the next time. And my x's did have a constant rate. So I need to reevaluate and see, okay, well, is there a number? It's multiplying by. So 3 to 9, okay, well, and if you don't know that number, take this 9 divided by 3, and that would give you it as well. That's going to be times 3. I'm going to write with a dot this time. Okay, so now we need to check. So 9 times 3, does that work? Yes. 27 times 3 is 81. 81 times 3 is 243. Okay, so this one would be our exponential. So I'm still doing f of x because my x's did not repeat. But my starting point, which I need to look at, so you want to think basically if I divide by 3, well, that would give me 1. And then so what number times 3 equals 3? That's 1. All right, so my starting point is 1. And then times, you put your multiplier next. So in this case, our multiplier was 3, and then to the x. All right, I could actually simplify this by writing, because 1 times anything is that same number, so I can just do it like this. F of x equals 3 to the x power. Oh, and I actually forgot to write on these if they were linear or exponential. I talked about it, but I didn't actually write it. So number 1 is linear, and 2 is exponential. All right, 3 and 4 are just looking at the setup, and I want you to go ahead and actually try the rest of these. I will say on 7, this is the line it's talking about. I don't know if it was clear on your copy. So take a minute, flip back to this first page of notes and see if you can identify which each of these types are. I'm going to pause the video as well and just write all the answers in. So make sure you pause and then replay when you're ready, or click play when you're ready to check your answers, okay? Okay, hopefully you're checking your answers. So 5, I got exponential due to the setup where it has x in the exponent. In that case, our initial value would have been 1.5 and the multiplier 2. 4, y equals mx plus b is the form it's written in, meaning that's linear, so -2 is the slope, 1 is the y-intercept. 5, that was a linear function, it was a straight line, so that's really all you need to know on a graph. In that case, I can see, all right, it crosses the y-intercept at 2, and it's going down 2 and right 1 each time, which is a slope of -2. 6 was a exponential function. Sorry, accidentally clicked off, so it may be a little blip there, but it was exponential on 6 because it was a curved line, so I can call that nonlinear. All right, 7 is a function. I want to talk about that. So like if it were a vertical line going this way, it would not be a function, but since it's horizontal, that is okay for it to be a linear and be a function. All right, and then in this case, I would do f of x instead of y, and that is just equal to 3, because from the origin, I go up 1, 2, 3, which tells me that's my y value. All right, and lastly, 8 would be exponential, because it is nonlinear and doesn't form a straight line. And that is all for today's lesson. Make sure that you complete today's homework, 3.4. Next class, you will have a review and you will have a quiz next week. So just make sure you are getting prepared for that and getting all your homework submitted. Have a good day.